Oh, this is Daddy from Austin and Daddy Doodle Doo. So the workout schedule is going good. That schematic I still want to think about. Let's make some space because recently, I got 20 tons of gravel. You wouldn't believe. I mean, it's all good. But you wouldn't believe how many people are like, "That ain't 20 tons of gravel, bro." I don't know what you're thinking. So we're gonna do a calculus lesson. All right. So here we have on this chalkboard a three-dimensional axis. All right. Oh, sorry. There we go. I need to look through the camera. Right, and the gravel pile kind of looks like like that, extruded, not uniform, right? So you can kind of see it. Let's get rid of these lines behind it, right? So it's a bunch of gravel, right? So the question is, how much gravel is that, right? So what we're going to do is we're going to approximate the shape of the gravel pile. Then we're going to calculate an approximate estimated volume of the gravel, and then we're going to look up the density of gravel and see if, in fact, we have what appears to be 20 tons of gravel or not. Okay, so again, we got this pile. We're gonna approximate it, the cross-sectional area of the gravel, right, on this axis as a trapezoid. Right, so we need to know how high it is. Actually, instead of measuring it, this is an axis, right? So right here, that is H, right? And how wide is it? So call that W. All right, that's cross-sectional area. So how do you do that? You take the top with, W bottom, right? WB for bottom, and W for top, or WT for top, right? So the way to find this area of the trapezoid is to average the top width or length, actually, depending on how you look at it, and the bottom one multiplied by the height, right? Don't believe me? Check this out. There's a triangle. There's a triangle over there, right? Now, the area of this rectangle, trivially speaking, obvious to most of us who know this, if you don't know, it's not obvious, is this whole width, right here, multiplied by H, the height, right? That's the area. Now we got two triangles. One triangle over here, one triangle over here. So what's the area of this triangle, right? Well, it's half of the area of this rectangle, right? Because this is a rectangle. That's half of it, all right? So we know that. So let's call it 1/2, and the area of this rectangle here is going to be the base width minus the top width, right? That's this amount here. So this is going to be a geometry lesson. Then we'll do a calculus lesson, right? So this is WB minus WT, right? That's it. And then H is the height, right? So length times width, or width times height, is the area. So the area of this whole rectangle is H times, the width of the base minus the width of the height. There we go. See that? And then multiply that by half to get just the triangle, right? Same thing over here, right? Because we're centering the whole trapezoid about 0. So this is the same. Right? You see that? So we're going to add, if it was different, it would be the same thing. Right? Let's say it's not. Let's say this is, let's say, since we're using an axis, let's call this point negative WQ. Right? And so the area of this triangle here would be 1/2 times H times WQ, and we'll call this point up here, right, WR, right? So WQ minus WR. Okay? So we take that piece plus this piece, right, over here, and then the middle here, right? So we were doing a symmetric trapezoid centered on the axis of 0, but let's say it's not, right? So then this value, this is WB, so we'll call this WC. So the area of this is just the sum of the area of this half plus that half, right? So this half is, the height is h, height is h times this W, actually this would be negative WC, so the value WC, right? And then this right here, WR, that's an R now. This would be H times WC. So if we add all those pieces together, we get 1/2, and it's going to be 1/2 of a sum. Well, let's just do it this way. This is a little bit of geometry, a little bit of algebra, right? So 1/2 of H times WQ minus WR, right? That triangle right there. Plus this one. Plus H times WR plus H. Oops. Plus, all right, so that's this one, right? And then this one, H times WC. Right? And then this triangle right here. So we got this, this, this. Now we need this, which is here. Plus 1/2 of H times, instead of using subscripts, I could have just used different letters, right? That would have been easier. Minus WT for top. All right, so we're going to simplify this. You can look at it that way if you want, right? Which is how I should have started this. Anyway, next time. So let's take the 1/2. So we'll pull, we have two different summed quantities multiplied by 1/2 and actually by H, right? See that? 1/2 H times this quantity. So 1/2